Back in January, AI agents were mostly viral party tricks. You'd hand an AI model complete access to your computer, and it would effectively slam on a keyboard until something happened. The core architectural flaw of that early phase was how entirely dependent it was on one specific intelligence. Every workflow, task queue, and security permission was locked inside a single provider's large language model. Relying on one LLM to act as your entire operating infrastructure creates a highly fragile environment. Hard work is difficult to assign to a single brain, and when that brain struggles with a subtask or drops context, the entire loop breaks. Building a business on a novelty wrapper tied to a single, isolated brain is a structural trap. It prevents an agent from executing reliable, multi-step adult work. The environment around these models is also getting actively hostile. In April, Anthropic restricted developer subscriptions because always-on third-party agent moots were running endlessly, generating massive token counts and draining Anthropic's compute margins. Conversely, OpenAI is taking the opposite approach. They are actively trying to absorb agent workflows natively into their ChatGPT and Codex subscriptions to capture the distribution of those background tasks. The consequence for developers is immediate and severe. If your agent relies entirely on one provider, your entire background loop crashes the moment that tech giant alters their API rules or metered pricing. Allowing your agent's survival to depend on the shifting corporate strategy of a single tech monopoly creates a fatal structural vulnerability in whatever you build. The April update to the OpenClaw framework introduces an evolutionary leap out of that trap. It shifts from being a fragile wrapper into what developers call a durable work loop. This schematic flowchart outlines that durable work loop. OpenClaw effectively built an independent body that manages the boring but essential infrastructure: task queues, retry behaviors, tool boundaries, state checkpoints, and message delivery back to Slack or GitHub. By separating these mechanical functions from the reasoning engine, this abstraction isolates your workflow from the instability and pricing churn of the underlying AI models. To achieve serious automation, the infrastructure, the actual body doing the heavy lifting, must be built to survive even if the brain is completely removed and swapped for another. Because the OpenClaw body is universally stable, developers can now dynamically hot swap different AI models, routing work to different brains based entirely on the complexity of the task. For cheap, high-volume, low-risk background classification, you can route the task to a local Google Gemma 4 model, keeping token costs near zero. For high-judgment code reviews or complex architectural reasoning, you switch over to the premium Claude API. And for hard implementation and complex repository patching, you can plug in GPT 5.5 Codex. An independent OpenClaw workflow can process a multi-step GitHub pull request by consecutively routing those exact steps to Gemma, then Codex, then Claude, entirely in the background without any user friction. The underlying AI model is no longer the product. The independent multi-brain workflow itself is the ultimate asset. But there is a flaw in a multi-brain system. If the workflow's memory lives exclusively inside one specific model's context window, swapping brains induces instant amnesia. The moment you hand a task to a new model, it arrives entirely blank. It lacks vital operational context, like past project conventions, lessons from prior deployment failures, and specific human instructions about tone or formatting. A highly capable reasoning engine operating with bad memory architecture quickly becomes a confidently wrong, unaccountable liability. A swappable brain workflow is functionally useless without a centralized memory layer that connects all those different intelligence engines together. This architectural diagram outlines the Open Brain project. It introduces an independent, user-owned memory layer sitting below the workflow loop. This external memory base records critical provenance for every action, logging exactly what failed, who authorized it, and crucially, the precise model ID. By combining the stable OpenClaw body with the Open Brain memory structure, you permanently insulate your operations from AI provider lock-in and pricing churn. Builders need to stop launching shallow chat wrappers. The real opportunity is in constructing vertical, durable workflow loops for tasks like incident response or code review, where you retain total ownership of the operating rhythm. The tech giants will wage a never-ending war over who controls the AI reasoning engine. But by separating the brain from the framework, OpenClaw ensures that you will